All right. Our first process in cellular respiration is called glycolysis. And as I mentioned previously, it occurs in the cytoplasm. Glyco means sugar, lysis means to break apart. So we're taking glucose and we're splitting it. There are two kind of major portions to this. There's an energy investment, and that means we're just going to be using ATP. And then there's an energy payoff where we're actually getting back the ATP and a little bit more. So here's kind of a broad overview. Energy investment, we use 2 ATP. We start with glucose. We use those ATPs. And then the payout, we actually get 4 back. So we end up getting like a net 2 ATP. And then meanwhile, we're taking NAD and we're adding electrons to it. And we're making NADH. And then the end product is 2 pyruvates. And the reason why that is significant is because that's like what's left over from the glucose, and those pyruvates will go on to our next processes. So we start out with glucose, and then each step here, you're going to notice that there's an enzyme. That's why we took the time to kind of go over enzymes and what they do. All right, so glucose runs into hexokinase, and we're utilizing an ATP here to phosphorylate glucose. I'm not big on you like memorizing all these like enzymes or steps or whatever, but there are it's actually something that is understandable if you sit down and really kind of study it. But every time you see a kinase, realize that something is going to get phosphorylated. In this case, hexokinase means we're taking the phosphate and we're adding it to a 6-carbon sugar. Then we go to the next step. We take something called phosphoglucoisomerase, and we're changing the shape of glucose from kind of this hexagon shape to a pentagon. So now it's fructose 6-phosphate, and then we take and we chop it, and we phosphorylate it one more time with phosphofructokinase, and then we're going to crack it in half. Keep in mind we're utilizing an ATP for that extra phosphate on there, and then crack. We got two different products, the dihydroxyacetone phosphate and glyceraldehyde 3-phosphate, and ultimately we want both of them to be glyceraldehyde 3-phosphate. And that's why there's this isomerase, so it can take the dihydroxyacetone and turn it into glyceraldehyde phosphate. And then that product is going to go on to the energy production phase. And so we're taking, and keep in mind, you see where it says glyceraldehyde 3-phosphate, keep in mind there's 2 of them, all right, for each one of these processes. But we're gonna take and we're going to oxidize that because it's losing electrons to the NAD to make NADH. So when you see this right here. We're taking the electrons out of these sugar-like things, and then we sneak a little phosphate in there because then we can take that and we can do we can phosphorylate ADP. So now we're at 0 total ATP. Before we'd lost 2 ATP. Now we just gained 2 back. So we're at 0 net. Then we're going to kind of change around like the shape of the molecule, and then we kind of strip out some water, and then the last step, we're taking out phosphate to make 2 more ATPs, and that's how we made our ATPs. And then we're left over with pyruvate, which is going to be the end product of glycolysis.